Hello, everyone, and welcome. If you're here, you're likely working on your master's in nursing education, which means you know that designing truly effective instruction is one of the most critical things you'll ever do. So today, we're going to break down the science of how your students actually learn from words and pictures. Think of this as a blueprint for building more powerful, more effective learning experiences.
Okay, let's just dive right in with the core challenge every single one of us faces. This quote really hits the nail on the head. Our main job, our entire job, is to bridge that massive gap between the textbook and the bedside. We've got to get our students ready for the fast-paced, high-stakes, and often unpredictable world of real clinical practice.
So here's our game plan for today. We'll start by talking about that theory-practice gap. Then we'll look at how technology seems to be the perfect solution before we introduce a pretty crucial twist. After that, we'll get into the real science of how we learn, connect that science directly to nursing, and wrap up by reframing your role as an educator.
All right, first up, let's really define this problem that, let's be honest, keeps us up at night. It's that huge leap from the controlled, predictable environment of the classroom to the chaotic, dynamic world of the clinic.
You know, the challenge is just immense, isn't it? I mean, it is one thing to memorize the steps of a procedure from a book. It is a completely different thing to actually perform it on a real, live human being, with their family watching, alarms going off, and a dozen other things pulling at your attention. That right there, that's the gap we have to bridge. And that, of course, brings us to what feels like the perfect solution: technology. It promises us this amazing, safe place to practice, kind of like a sandbox, where our students can learn and, yes, make mistakes and grow, all without any risk to real patients.
And listen, the benefits are obvious and they're really well documented. Clinical simulation, for sure, gives us that safe environment. But it does so much more, right? It sharpens clinical reasoning, it helps cut down on errors, it builds teamwork, communication, it really hones those critical decision-making skills. It seems to tick all the boxes.
So whether you're talking about slick VR setups, screen-based scenarios, or those incredibly realistic high-fidelity mannequins, technology-enhanced learning really does look like the hero we've all been waiting for. But there's a catch. And here it is. This is the essential twist. The conversation can't just be about the cool new tech. We absolutely have to shift our focus from being technology-centered to being truly, deeply learner-centered. This is the question that should be on our minds all the time. We've got access to these incredible, amazing tools, but is the way we're using them actually helping our students learn? Or are we just delivering the same old information in a shiny new package? Now, this is so important. This distinction comes from the work of a researcher named Richard Meyer. A technology-centered approach asks, hey, what can this cool new VR headset do? But a learner-centered approach asks a totally different question. How does the human mind actually learn, and how can we use technology to support that process? See the difference? The whole starting point changes. And this table just perfectly illustrates that mindset shift. It really forces us to ask, are we stuck in that information acquisition metaphor, where our job is just to dispense facts to a passive student? Or have we moved to knowledge construction, where we see the student as an active sense maker, and our role is to be their cognitive guide, helping them build real understanding? So that brings us to the real heart of this whole thing. If we're going to be cognitive guides, we need to understand the science of how people actually learn. So let's get into the evidence-based principles of multimedia. First things first, let's get a simple definition on the table. Multimedia learning is not about the technology. It's a cognitive process. It is what's happening inside a learner's brain when they're actively trying to make sense of information that's coming at them in both words and pictures. So, here it is, the single most important finding from 30 years of research. It's called the multimedia principle, and it's beautifully simple. People learn more deeply, more meaningfully, when we combine words with relevant pictures. Not just text and more text, but words and pictures. It's a game changer. Let's make this real. Look at this classic bicycle pump example from the research. Now, if I just describe to you how a pump works with my words, you might remember a few facts. But when I show you an animation like this while I'm explaining it, your brain can connect the dots and build a complete mental model of how it all works. You don't just remember it, you actually understand it. Okay, so we know words plus pictures are the winning combination. But what about the words themselves? How should we present them? Does it actually matter if they're spoken as narration or just printed as text on the screen next to our animation? This is a huge design choice you have to make every single day. Now, this diagram might look a little complicated, but the idea behind it is really simple. Look at the top half. When you show an animation and a bunch of on-screen text at the same time, you've got two sets of visual information, the pictures and the printed words, trying to cram through your eyes, your visual channel, all at once. It literally creates a cognitive traffic jam. The brain gets overloaded and learning just tanks.
And this leads us to our second major design rule, the modality principle. To avoid that cognitive traffic jam, you should present your words as spoken narration. This lets the animation flow through the visual channel, the eyes, while the narration flows through the auditory channel, the ears. You're using the brain's full processing power. It's way more efficient, and it leads to much deeper learning.
Okay, so how does all this cognitive science stuff actually apply in our world? Let's bring these principles right back home to the unique challenges and goals we have in nursing education. In nursing, our goal can never, ever be simple rote learning. Just memorizing facts might get you through a multiple choice test, but it is awful for what we call transfer, that crucial ability to apply knowledge in a grand new clinical situation. We are always aiming for meaningful learning. We want to build organized, integrated knowledge that our students can actually use in the unpredictable reality of patient care. And here's the really cool part. You're already using these principles, maybe without even realizing it. Just think about the structure of a high-fidelity simulation. Pre-briefing, that's preparing the mind for learning. The scenario itself, that's the rich visual and auditory experience. And debriefing, that is all about guiding that active construction of knowledge. Best practices in nursing education are already perfectly aligned with the science of learning. So let's wrap this all up by focusing on the most important piece of the entire puzzle, you. Your role isn't just to teach, it's to design experiences that genuinely build understanding. Please remember this quote. It is not about having the fanciest, most expensive simulator or the latest VR software. A well-designed, thoughtfully narrated PowerPoint that actually follows these principles can be far more effective than a poorly designed high-tech simulation. It's your thoughtful design, your architecture that matters most. So I'll leave you with this one final question to take with you. As you design your next lesson, your next simulation, your next course, I want you to ask yourself, am I just delivering information, or am I carefully, intentionally, and scientifically architecting an experience that will build true, lasting understanding in my students?